Hello students, in this video we will discuss numericals in regression. Um, a regression model is described as a linear equation as follows. You take this equation, here x is an independent variable, y is a dependent variable, and there could be many predictor variables such as x1, x2 in a regression equation, but here this is an example for uh, single independent and single dependent variable equation, right? And this last term is the error term, random error term. And here we can see an example. We have to predict the glucose level for the age 55 given 6 instances of ages and corresponding glucose level. And for understanding it easily, this age is represented by X and glucose level is represented by Y. First, what I have to do is like using the regression technique, I have to predict the relationship between this independent variable and dependent variable. So first 6 instances are there, right? Using these 6 instances, I have to predict the relationship between this independent variable and dependent variable. After predicting this, you can find the glucose level for the given age 5. So um, here you see this equation. You have, as I said, this is independent variable and this y depends upon the value of x. And you have few more terms like beta naught and beta 1. And it is like your slope intercept formula. Y is equal to mx plus b, and you have an error term. And if I want to predict the relationship between this x and y, then only I can substitute the value of x as 55 and I can get this corresponding glucose level. So I should know this, what is beta naught value and what is beta 1 value. So I have some formula, use this formula and find the value of it is beta naught or b naught, beta 1 or b1. So these are the formulas to calculate the value of b naught and b1. So b naught is equal to summation of y into summation of x square minus summation of x into summation of xy by n of this is n stands for number of instances into summation of x square minus summation of x the whole square. Similarly, beta 1 formula you have. So with this given two columns, you had only age and corresponding glucose level. Along with these two columns, I am adding few more columns like xy, x square. So what and all I need in this formula, I need xy, I need x square. So I'll be adding those columns. xy, you multiply 43 into 99, write the corresponding value. 21 into 65, write the corresponding value. Similarly, x square, 43 square. 21 square, write this. Y square, it is not needed in this formula. Even if you don't write this, it is fine. So next you check the formula. Everywhere I need this summation. So you find the sum of all this x, y, x square, everything. And then substitute those values in the corresponding formula. You will get the value of b naught. Similarly, you will get the value of b1. Now you can write y is equal to b0 plus b1 x. That is, what is the value of b0? It is 65.14 and 0.3853. 65.14 into 0.3822 into x. Now this is my model. This is my model. After that, what you have to do, you have to find the value of y when x is 55. That is my question. That is my test data. So you substitute 55 in the place of x and find the corresponding y. So you will get us 86.327. Right. So the glucose level At the age 55 is 86.327. Right. So this is how we can calculate the dependent variable for a single independent variable. These are the steps to calculate the dependent variable given a single independent variable. Next we can see, right, one more numerical, one more sum here. Given two independent variables, x1 and x2 are independent variable and y is the dependent variable. 5 instances are given, and the sixth is your test data. The value of the independent variable x and y, x1 and x2 is given. You have to find the corresponding value of the dependent variable y. Dependent variable y. So here there are two independent variables. So the method is little different from the previous one. Here you check it. This is the formula for multiple regression model. Right, multiple regression model, y is equal to y intercept plus beta 1 x1, beta 2 x2 up to beta k xk and the random error. All this beta 1, x1, x2 are the independent variables. Right, x1, x2, xk are the independent variable. And here in multiple regression, what I have to do is, like, first I have to calculate this y intercept. So if I want to calculate this y intercept, how will you write this formula? Y intercept is equal to y. You will bring all these population slopes to the other side, right? Now, so here it will be y intercept is equal to y minus beta 1 x1 minus beta 2 x2, and it goes on. That's how I got this up. So this is my y intercept, which is equal to y minus b1 x1 minus b2 x2. And next I want to calculate this b1 and b2. So the formula is given. These are the formulas to calculate this b1 and b2. And if you check this formula, summation of x2 square, all this x and y are small letters. Summation of x1 y, summation of x1 x2, summation of x2 y, and it goes on. This x and this capital X are different. This x and this capital X are different. So to get this summation of x2 square, I have another set of formulas, right? So sigma x1 square is equal to sigma capital X1 minus summation of the first variable into summation of the second variable by n, total number of instances. And similarly, you have the formula for x2 square, x1y, x2y, x1, x2. Right. So what you have to do is, like, first rewrite the given tabular column. So this is your tabular column. Initially, you had been given with y and x1, x2. Now you need these values. Right, x1, x1, x2, x2, x1y, x2y, x1, x2. You need these values, so you can rewrite it. X1, x1, x2, x2, x1, x2, x1y, x2y. So what is this x1 into x1? This 3 into 3, 9, 4 into 4, 16, 5 square 25, 6 square 36. Similarly, x2 is 8 square 64, 5 square 25, and it goes on. x1, x2 is 3 into 8, it is 24. Like this, you have to fill this column. x1, y is 3 into minus 3.7. You'll get the answer is minus. You have to fill it. Similarly, you have to fill for x2, y. Next, you substitute all this, find the summation and substitute all these values in the given formula. You'll get these as the answer. Now, you have to use these values, sigma x1 square, sigma x2 square in calculating this b1 and b2. You'll get these values. Apply it in the slope intercept formula. You'll get 2.797. Next is, you have to calculate your y, which is equal to b naught, that is your slope intercept, 2.796 plus b1 is 2.28 minus 1. And you can check here, the B2 value is minus 1.67, so it is minus 1.67. So here we got this y. What is y? Y is equal to slope intercept. I'll show you the formula. Y-intercept, right? Y-intercept plus B1x1 plus B2x2. Y is equal to Y-intercept B1x1 plus B2x2. Y is equal to Y-intercept plus B1x1. Since it is minus here, it is minus B2x2. So now you got the value of x1 and x2 as 3 and 2. Where you have this value, these are the test data. When the independent values are 3 and 2, what is the value of y, which is a dependent variable? You calculate it, you substitute, calculate, you will get the value of y is equal to 6.296. Right, so this is all about calculating the dependent variable y given two independent variables. Thank you.